Hello and welcome to Talking Steam, a podcast series by Spirax Sarco. We are the world's leaders in steam technology, offering the industry's most extensive range of products and services across a variety of industries. We create solutions that set the benchmark for steam-using organizations worldwide, working with you to improve productivity, save energy, and reduce waste.
Welcome to the Talking Steam podcast. In this episode, I'm joined by Michael Stamm, a first-line sales engineer from the Frankfurt area in Germany, where we will be discussing the considerations that need to be made when recovering flash steam. In this episode, we will be looking at how to reuse the energy and water that can be recovered from a flash steam plume to achieve the maximum possible energy and water savings. As a precursor to this, we will also be exploring the need to identify the controllable and the unavoidable losses from a steam system which manifest themselves as visible plumes, and then look at the steps that you can take to recognise and control these. In the last episode, we learned from Katerina Rosa about the true cost of flash steam plumes when they are left to discharge to atmosphere. She shared a story about a coffee manufacturer she worked with who was experiencing pressure from the local community to reduce their visible steam plumes from site, and how they were also able to reduce the energy and the water consumption of their plant by recovering the flash steam. We also discussed the potential health and safety risks that can be presented by a flash steam plume and how to bring these under control. My guest today, Michael Stamm, is a qualified process engineer with more than 30 years of experience. Since 1998, he has built his experience in steam with Spirax Sarco and is a specialist in heat exchange applications. I'm Mike Skidmore, your host for the Talking Steam podcast, where in this series we are focusing on heat recovery opportunities at food and drink manufacturing sites. Just a quick note to say that due to the COVID pandemic, this interview was held virtually rather than face-to-face. Michael, thank you ever so much for joining me and welcome to the podcast. For the benefit of the listeners, can you describe where you're speaking to me from today?
Yeah, hi Michael. Nice to meet you. Yes, I'm locating near Frankfurt and speaking to you from my home office. It's near Frankfurt in a small village called Aschaffenburg. No one knows in the whole world, but they are located and speaking to you.
Fantastic. And of course, working from home because of COVID restrictions, no doubt.
Yeah, it's very, very comfortable to work at home. So I'm organized to work from home and to drive out to the customers from my home office space. And that's very comfortable. During COVID time, it makes not a very big difference to non-COVID times.
Understood. And so in the past few episodes, I've spoken with other guests about the plumes of steam that exist on site and why they occur. And that led to us identifying two different types of steam plume. One being the controllable losses, such as leaks from steam traps or safety valves, and then the other being the unavoidable losses, such as from production processes where the pressure change in the condensate leads to the presence of flash steam, and that flash steam being the plume that is recoverable. But before we are able to recover the heat from the flash steam generated by those unavoidable losses, we must take measures to ensure that we have eliminated the controllable losses from those plumes that you see on a typical site. So Michael, the first question to you really is, from your experience, what is the most common cause of controllable losses at a food or drink manufacturing plant?
Yeah, the most common cause is leaking or passing steam traps. To explain in a few words what is the task of a steam trap and what a steam trap itself it is. The steam trap itself is the interface between steam and condensate side. We have different types and working principles over all manufacturers, and a very, very important issue in this case is the differential pressure. So if you have, regardless of the manufacturer, steam traps will from time to time will fail. This depends on their serviceable life, and they will fail in normally two ways. They can fail in an open or in a closed way. In the most cases, due to the construction of the steam traps, they will fail in open conditions. Why do we construct this in an open failing procedure? It is done because if it fail in an open position, you have no restriction to the process. But in the opposite side, if they fail open, you have, of course, you will have leakage, and you will lose fresh steam. And if you take in consideration that a plant can have tens or hundreds of steam traps, and if we have a failing rate of maybe 10%, you can assume that a lot of steam traps, and that's a normal way of life, will fail and will leakage through, and they will have fresh steam losses.
Okay, so from what I can gather from that, it means that actually a manufacturer who has got a steam trap that is failed open wouldn't necessarily see any symptoms in their process because their process would keep on running. It just means that you would have that plume downstream of the live steam being emitted to atmosphere.
Yeah, that's right. You will lose a lot of steam, and if you take, maybe you have a production line using 1 or 2 tons of steam, fresh steam, for heating something in the production, and you have a loss of maybe 10%, you can assume this is a lot of kilograms per hour of steam loss, which is controllable.
Absolutely, and
yeah.
the cost with very quickly into tens of thousands of pounds or euros or dollars worth of losses per year as well.
Yeah, and the costs will rising more and more over the next years because the energy costs will rise more and more.
Okay, so Michael, when we're looking to recover heat from a plume and controllable losses are present, what steps would you take to make sure that those controllable losses have been removed and ensure that it is only flash steam that is present?
Yeah, the first of all, if you want to control something, you have to measure it in front of it. And the first step to measure the plumes, the flash steam in a right way is to eliminate the fresh steam losses, the controllable losses. And to do this, you have to make a steam trap survey. It's absolutely necessary. You have to check every steam trap in working conditions. And then you can have a list and a table, and you see, okay, 1, 2, 3, 4, 5, 6, whatever else numbers of steam traps has failed, and they produces controllable losses. So then you can maintain these or exchange them with new models, and then you are only then you are able to measure the flash steam which we want to recover.
So now that we've explored the controllable losses and the considerations that need to be taken, and we've spoken about the trap survey and using that to help remove those controllable losses from the plume, I think it's fair that we need to now start talking about the practical considerations involved with recovering flash steam. So when we think about that flash and how it's generated, can you give a few examples, or can we discuss a few examples of applications and processes in food and beverage manufacturing plants that would typically be responsible for generating flash steam?
Yeah, some out of my experience, 2 typical applications where you will producing flash steam is steam jacket cooking vessels or hot water generations. What is the similarity between these 2 applications? Both have using high temperature to heat a medium to a higher temperature up. And if you think high temperature at steam means high pressure at the steam. High pressure, high temperature, it's one and the same at steam. And all these applications with high temperature or high pressure steam means they're producing a high flash steam. Generally speaking, high pressure to low pressure means high flash steam amount.
Fantastic. And as you say, the steam jacketed cooking vessels, which you would normally see in soup or sauce manufacturers, and then also that hot water generation, which I think most food and beverage manufacturing sites would have for their washdown and their hygiene facilities, are two prime examples of where flash steam would be generated from. I think others that spring to mind from my experience when I've been working with manufacturing plants have been applications like indirect pasteurization, so where the steam is providing heat but not being directly injected into the product, but it's trying to sterilize. Key ones have also been things like retorts and autoclaves, especially in, say, the manufacture of dog food or tinned foods, where you have a sealed product and you're using that steam to provide, again, sterilization around the outside. Dryers, for me, have been a huge contributor to flash steam too. So very much in like the meat rendering industry, or where you are drying a slurry to create almost like a powdered product. And that's normally in like a jacketed dryer, where you have a screw through the middle, or even like your rotary drum type dryer, which I think we come across quite often around the world. And then also another type of system that's very common across all manufacturing plants, and one that I've certainly seen, are also CIP systems, where the steam is being used again to heat water and heat other fluids, and we can quite often see a reasonable amount of flash being generated from those too. So some great examples there.
Yeah.
When we think about those processes that are producing the condensate that then generates the flash steam, that condensate's often collected in a vessel at atmospheric pressure due to it having a vent. Michael, where can you often expect to see those plumes coming from when you think about the layout of a typical manufacturing site?
Yeah, typical manufacturing site. There are different sizes at these sites, and if you think of a small site, you will have one recovery vessel bringing back, normally located in the boiler house. So you have only one point. You can see the fumes coming out of this recovery vessel. If you're thinking of bigger sites, you have in each building, for example, one recovery unit, one recovery vessel, additional maybe 10 buildings together feeding in one bigger recovery vessel, and this vessel feeding back to the boiler house. So that smaller plants, you have only one or two points you can see the blooms.
Okay, understood. And Michael, it's actually the first time in this whole podcast series that we've spoken about the boiler house. And just for the benefit of the listeners, can you explain to us just for 30 seconds why we would normally see all of this condensate being returned in the direction of the boiler house?
Yeah, you will transfer the condensate to the boiler house because the condensate is, on the one side, it's hot water. It's containing, therefore, a lot of energy. And on the other side, you have chemicals inside, and the chemicals are also expensive. So if you don't feed it back to the boiler house, you will lose a lot of water, energy, and chemicals. If you feed it back to the boiler house, you have only to add the amount of water and chemicals and energy which you have lost through flash steam. So you spare a lot of money if you feed it back. That's the main reason. It's absolutely necessary to feed it back. Otherwise, it's economic disaster.
I think it's fair to say with that certainly returning that condensate back to the boiler house is one way of closing the energy loop, recycling that water and that energy, ultimately eliminating those losses. When we talk about somewhere energy that we've spoken about, we often refer to that as a heat sink. And that would be an application or a process where the recovered energy can be used. And that is often a system where fossil fuels or energy input is used to heat another process, and where this recovered energy can take that place and ultimately save the money required that would have previously been adding heat. So, Michael, from your experiences and from the projects that you've worked on, where is the best place to recover energy from flash steam when we consider a typical steam system at a food and drink manufacturing plant?
It is the best to recover the energy at the point of emergence, to avoid additional losses. So if we're thinking in a typical example, you have a building, you have a process inside the building, and the condensate will be returned to a recovery vessel, and at the recovery vessel there will the flash steam arise. And it is the best place, the best point to recover it, recover the flash steam energy, is the place at the recovery vessel. And additionally, you have to take in consideration, where do you have the heat sink? Where can you transfer the energy from the flash steam to a new process or whatever else? So the challenge is to find a heat sink and to find it at the right place. It makes normally less sense, out of my experience and the different projects we have managed, to transfer energy from one side of a plant to the opposite of the plant, about 500 meters or 1 kilometer or something like this. This makes no sense. So you have to be inside the building, near at the process. And then you can transfer the flash steam energy very easily to, for example, to another product. You have to preheat or you want to preheat water for cleaning purposes, to preheat the water before it is heated up to the end temperature you want to have. So every preheating is a suitable choice to recover the energy. Yeah, and then you have to take into account that flash steam recovery means also you have lower temperature. The temperatures are not so high you can recover. You have temperatures normally below 100 degrees C. And so you need heat sinks which need no higher temperature, or you can use it as a preheating, as I stated a few sentences ago.
Fantastic. So I think what we can take from that is when you say that the heat sink is ideally as local to the flash steam plume as possible, that would mean that if, say, the flash steam was coming out of the boiler house, then to find a water system that would need preheating, such as the feed water going into the boiler, would be a fantastic heat sink. And similarly, if it was a process or production building where the flash steam was coming out of a particular process, you would want to find another process that is local again to that flash plume, or be able to feed it back into the front end of the process.
And also very important is to find a place which is continuously working. So it makes no sense to recover energy 24 hours, 7 days a week, and you have only a heat sink which is working 1 or 2 days per week, or only a few hours per day. It makes no sense. So you need an heat sink which is simultaneously working to the flash steam process, or completely independent, but at the same time you need all the time you can recover energy. You need the time slot to use the energy, and this is very important. Otherwise you have to take into consideration some storage possibilities, for example, to heat up water, storage it for the time you don't use it directly, and then you use it in the nighttime maybe, or in the second shift or something else. So storage is another possibility to optimize such systems.
If you're not able to recover the energy live, almost straight back into another system, you're saying it is possible to then use some kind of buffer system, some kind of storage medium like a hot water tank, to enable that some of that flash steam to be captured and of course increase the amount of savings that you have. There is opportunity there to have some kind of hot storage which can be used later that doesn't rely on the synchronization of two systems. Then I think there's some significant savings there that could be realized if that kind of methodology is employed.
And all the things are also depending on the price of the energy. So if the energy is cheap, maybe it makes no sense. But if the energy costs will arise, and they will do, then it's more suitable to take this in consideration.
Of course, and I think what's also fair to say is there are a number of locations around the world where the energy may be cheaper, but the cost of water and the scarcity of water means that the savings associated with recovering flash steam make it viable just on that payback alone.
Yeah.
And that there is always that kind of holistic view that you need to take as far when it comes to the recovery here. Michael, just touching on the steam trap surveys that you mentioned, who would normally carry out a steam trap survey, just for the benefit of the listeners?
It should be done by persons who are experts in steam, who know what is steam, what is flash steam, what is pressure, what is temperature, who know the different principles of a steam trap. Yeah, and what's also very important, they should have a lot of knowledge about the process in the relevant companies they are checking the steam traps. Because if you know the processes, you know what to do, or what is the normal optimum steam trap relating to the different principles, and then you are able to judge it right and say, yes, it's the right steam trap at the right place at the right process, and it should be in an operating cycle like this per definition, and it isn't. So it's leaking or it's blocking, and mainly it's leaking, but it should be a steam expert. It is not good idea out of my experience to be done by the own people in the plants. They do it and they think they are doing it right, but in most of the cases they do it once a time, maybe only every 2 years if they have time, and that's not enough. You have to do it regularly, and you have to do it every year, and you have to track your measurement. But because only if you track it, you can have trends, you can see trends, what happened in the process, what happened with the steam trap, and maybe there are mistakes in the installation, and then you can find it. If you don't do this, it's just a flashlight, and it's only one day. You see it's right or wrong, and 1 week later, maybe it's breaking down. So it should be experts.
Yeah, and I think just touching on that point there, it's really key to reiterate that just like any kind of inspection, it represents a snapshot in time, and that things can change by the day, by the hour, by the week, and the more regularly it can be done, the more opportunity there is for energy savings and also the optimized function of a plant as well. And you know, an adequate trap survey is more than just a visual inspection. It involves the most common ways to ultrasonically monitor the traps on the site to make sure that they are working correctly, that the leakage, or if there any failure that may have happened, is not just identified, but it's also quantified as well, to say how much leakage is actually occurring there, and then how much leakage is occurring, which could then be visible and emitted from the site as a visible plume, an energy loss, and also a water loss. So, Michael, just before we wrap up, I've got one more question for you, and really, it's what is your final piece of advice for any food or drink manufacturer who is interested in capturing the heat energy from their steam plumes at their site?
My advice is involve steam experts. Involving steam experts is always a good idea. Making a walk through the plant, looking at the steam traps, checking the steam traps, looking at the whole process, maybe in conjunction with the audit, energy audit, and then you have the possibility and the chance to find energy losses, water losses, fumes, plumes going outside, and you have a chance to find the right heat sink and to recover energy. And at the end of the day, there is really, in the most cases, you find the possibility to spare a lot of money and to optimize your process and or to optimize the production.
Brilliant. Well, thank you ever so much, Michael. I think that's been some excellent insights there from you, talking from an awful lot of experience as well. And all that's left to say is thank you ever so much for your time here. And I look forward to having you on another podcast episode in the future.
You're welcome.
My thanks to Michael Stamm for discussing the practical considerations that need to be made when recovering flash steam. What we can take away from this episode is the importance of recognising the source of a plume of steam and making sure that it is an unavoidable loss. This is flash steam created as a byproduct of the process, rather than a leaking steam trap, which we would identify as a controllable loss. As well as identifying the source of flash steam, we must also have a suitable heat sink, with the right fluid temperatures to accommodate the energy, and one that is synchronised with the processes to ensure as much energy as possible is recycled. Of course, we can also look to use a means of storage to accommodate any excess energy for later use in, for example, a hot water washdown system. Join me in the next episode where I'll be speaking with an expert to learn from their experiences of putting heat recovery into practice within the food and beverage industry. They will be sharing the lessons learned from a real-life project, explaining how the topics covered in the past 3 episodes of this podcast were implemented and the outcomes that were delivered for their manufacturer. All of the information discussed throughout this series of a Talking Steam podcast is now available, summarised in a handy e-guide for you to download and keep. Use the links in the description to access this, or find it on our website by entering Spirax Sarco Talking Steam into your search engine. Thank you for listening, and I hope you continue to join us on this series of Talking Steam.
Thanks for listening. We hope that you enjoyed this podcast and join us again soon. If you have any questions about the content covered in this podcast, please reach out to us or your local Spirax Sarco engineer. Watch out for future episodes coming online soon. Follow Spirax Sarco on LinkedIn and listen to get updates on new episodes.